Okay, welcome to Chapter 7, Lesson 3, Similarity and Transformations. Learning target or objective for this one is to use transformations to create similar figures. Do have one vocab word for this lesson. It is similar. And similar means if a second figure can be obtained from the first by a sequence of transformations and dilations. That's what we're shooting for, similar this lesson. Similar that we are looking for is that if a second figure can be obtained from the first by a sequence of transformations and dilations. Okay, once again, you can always pause the video to write down your definition as we will proceed. Okay, well, we have a couple words that we're going to be using this lesson: dilation, scale factor, and similar figures. We've seen these in the last chapter. What I want you to do here is to write down in each one, if you know it well, have seen it or heard it, or you have no clue what it is. And then if you do, obviously if you know it or have seen or heard it, write down what it means. If you have no clue, take a guess. And those three definitions right there, as we will proceed to our first example. Okay, determine if the two triangles are similar by using transformations. Okay, it's going to be a two-step part. So first, we're going to try to see if we can do it by how we can figure this out. If they are similar. And let's take a look. We're going to take triangle DEF. We're going to clone it. Try to. There we go. We're going to take it. Possibly. This wants to move. There we go. DEF. And if we slid it over and down, we meshed it up point to point. Looks like we possibly could have similar triangles that way. So if we translate it or slide it over, they are similar in shape and form. But now let's take a look at different. There's another step we have to see. We're going to be using ratios to determine to see if they are similar. And how we can do that on without any angles or sides, but we can count our squares. So let's look at side HG. Let's move this one out of the way. Let's move you back over here. HG. We got HG. We have 1, 2, 3, 4, 8. That is 8. Our side that would be similar congruent to ED would be ED. Let's count 1, 2, 3, 4. That is size 4. So basically what we're going to do is we're going to do a ratio or a scale factor to see if they are similar on all sides, if we have the same scale factor for all three sides. We're going to take our big triangle and put that on top. So H4, if we divide that out, it's 2 over 1. Okay, so that's our ED side. Okay, now let's look at our GI. GI, 1, 2, 3, 4, 5, 6. We have DF, which would be their congruent side over there, 1, 2, 3. So once again, we're going to put 6 over 3. So that is 2 over 1. Can we reduce it? 2 over 1. So far, the ratio is the same, so that means these triangles so far are similar. Now we still have to do our HI. If we count HI, 1, 2, 4, 5, 6, 9, it's 10. And over here, 2, 3, 4, it is 5. So we have 10 over 5, so just 2 over 1. So our ratios figure out it's the same, as well as our dilation, or as our translation slid over, showing us we had similar triangles. So there are two ways to determine if these two triangles are similar: by translation and also by our ratios. Each side is a 2-to-1 ratio, so they are similar triangles. Any questions, please write them down or review. The diagonal is a little tricky, but if you have two sides that are similar, the diagonal is always going to be matching up because if it's a triangle. they have to, if two angles are the same, or two sides are the same, the third one is going to be as well. Okay, let's take a peek at our next example. Okay, this time we have rectangles. We're going to try to see if they're similar by transformations as well as ratio. Okay, our first thing how we can do, let's try to get our rectangle TUVW. See if we can get it to a similar way as WXYZ. First, let's rotate it. Let's rotate it 90 degrees clockwise. So we're going to rotate it 90 degrees clockwise this way. There, 90 degrees. We're going to have a 90-degree angle right there. So T is going to move up 2, 3, 5 spots. 1, 2, 3, 4, 5. So our new T will be right there. We move over 3 spots. 1, 2, 3. U would be right there. V would stay there, and W would remain the same. That's our rotating vertice. So as you can see on our new shape, it does look similar to our XYZ rectangle. So just by looks it is, but now we're going to do our ratio once again. So now let's count our WT. WT we just counted up. That was 5. And that is going to be similar to, not WZ, it's going to be sliding it over, it's going to be similar to XY. XY is 1, 2, 3, 4, 5, 7. This time we're going to use our smaller triangle at the bottom, or at the top. So 5 over 7, rectangle I should say. So 5 over 7, can't really reduce that, 5/7. So let's see if our other ratios match up as 5/7. Now let's take a look at UV. UV is going to be right there. Once again, that is 5. And that's going to match up with WZ, which will be 7. So those two ratios will be 5/7. So far, so good. Now let's take a look at TU. TU is 3. And we're going to look at YZ. YZ is 1, 2, 3, 4. 3 over 4. Well, that doesn't match up. And once again, VW, 1, 2, 3 at the bottom here. X is going to be 4. That is 3, 4. So the ratios do not equal out on all sides. They all have to have the same exact ratio to be similar. So they do not. So these two rectangles are not similar triangles. They were on our transformation, on our rotation, they did look similar, but then once you got to the ratio part, they were proven not similar. So again, any questions, write them down or review the video. We're going to slide on to our next example, our real world example. Ken enlarges the photo shown by a scale factor of 2 for its web page. He then enlarges the web page photo by a scale factor of 1.5 to print. The original photo is 2 inches by 3 inches. What are the dimensions of the print? Are the enlarged photos similar to the original? Well, let's take a look at what we got. And oh darn, Ken is a Michigan fan. Figure that one out. So, what we need to do, first of all, we're going to write down our original. Original photo is 2 inches by 3 inches. 2 by 3. That is the original. So I want to write that down. Original is an abbreviation. So now, by scale factor of 2 for his web page, he enlarges it. Remember, on our scale factor, we multiply. We're going to multiply each one by 2. So we have 2 times 2, which is 4, and 3 times 2, which is 6. So that gives us our web page photo. 4 by 6 is the web page. Now then he enlarges the web page photo by a scale factor of 1.5. So now it's another step. We're going to take our web page size, which is 4 by 6, and we're going to multiply that by 1.5. So multiply 4 by 1.5. You get 6 inches. We're going to multiply 6 times 1.5, and you're going to get 9 inches. And that is the print size. The print size would be 6 by 9. And that is the print size. That answers one of our questions. What are the dimensions of the print? 6 by 9. Now our other question, are the enlarged photos similar to the original? And that answer would be, yes it is. They're similar by, they were just dilations. Remember, it's still similar, just enlarged. So are the enlarged photos similar to the original? Yes, they are. So again, it's a two-step process. We did have that last chapter on dilations. Okay, any questions on this one, please write them down or review the video. And this concludes lesson 3.